Okay, my game dev else, here is a sneak preview what we are going to create. So we have these meshes that we'll be able to destroy, and we are going to see how we can destroy these meshes, as you can see. Now we can create or we can convert anything we have in this level into a destructible mesh. For example, this is a big wall, and I can go here, select my static mesh over here, and for the elements that I want to destroy, click here plus button and find big wall. There you go. And if I hit the play button, turn around, there you go. Now this wall is a destructible one, and we can do basically with any stuff you have in the level. Even your grandma, you can put it here and she'll be destructible. Okay, so let's see how we can make a destructible grandma. What is crack lacking, my game dev gangster? Before we start, I'm going to point out that this is not a beginner tutorial, so make sure that you have a prerequisite knowledge, because I'm not going to explain every single thing in detail. I expect you to know some stuff. Also, in order to follow along with this tutorial, you can download the project, which is down below in the link. So just go on awesomeswitch.com, sign up, and you will receive this project. So what do we have over here? Well, we have a nice little level. If I hit the play button, we have this player who can shoot these projectiles that are not moving, that we are going to fix in a second. And we will be able to convert anything we see in this level into destructible. So these right here, this right here, this right here, whatever you see, we will be able to do that. And in order to do that, we have this proc mesh actor or procedural mesh actor. Now, by the way, over here inside of the destructible procedural mesh, we have 4 blueprints that are the core of this project. So we have this proc anyways, proc mesh actor. This is how it is called. Anyways, this is going to be our actor that has this procedural mesh that we are going to use to, create these meshes over here. And this right here, this bad boy static mesh, or this actor, I'm not going to pronounce everything because I will, it will be complicated, but he is the one that will be responsible for converting all of the meshes from the level into destructibles. So let's do that. Over here inside of the variables, I'm going to right click and I'm going to call this one static meshes to convert. Now this right here is going to be an array, as you can see, but it needs to be a type of static mesh actor. So it's static mesh actor with object reference, and it needs to be an array, as you can see over here. This array also needs to be a public array because we have this object over here inside of our game. Here it is, BP static mesh to proc whatever. And then over here inside of this array, we are going to add meshes that will be converted. But before we do that, let's go over here, and it's going to happen in the event begin play. We're going to enter a for each loop, and the array that we're going to loop through is going to be our meshes to convert, which is going to be plugged in over here. What's gonna happen is, first things first, I am going to test if is valid, which is going to tell me if the object is valid or not, and the object that I want to test is going to be the array element. Next, I'm going to go here and I am going to say spawn actor from class, and the actor that I want to spawn is going to be our BP proc mesh actor, which is this one over here, as you can see. Now we are going to spawn him at the same location where our array element is, so we're going to say get actor transform. And then we're going to plug in this transform over here because this is where we are going to spawn the new actor, as I already said. Next, from this array element, I'm going to get the static mesh. So not set, we want to get. So let me just see here, get, if we can get that. So not the materials, but I'm going to do it like that. So there you go. So we want the static mesh component, and I'm going to move this over here so that this can go over here like that. And voila. So what we are going to do next is that we are going to copy. So from here, copy procedural. So procedural, this is what we want, this right here. So copy procedural mesh from static mesh component, and that static mesh component is this one over here. So I'm going to plug it in, so it's going to copy a procedural mesh from the static mesh component. Now over here, from the return value from our BP proc mesh actor, we are going to get the procedural mesh, and it's right here at the bottom. So we're going to get that, and we're going to plug it in over here to the proc mesh component. We're going to create collisions so they will be able to collide. We are also going to set the material. So from here, set material like that. And I am going to move this here. This goes over here. The material is going to be set over here like that. And I am going to set this MI mesh. That can be our material. And after that, we want to destroy. So destroy actor. And who are we destroying? Who is the actor that will be destroyed? Well, it is going to be the array element actor, which is this one over here. So I can drag this from here all the way from here and plug it in, something like that. There you go. So basically we are going to create a procedural mesh that can be destroyed, copied from our original mesh that we will now attach to this array. So compile and save, and let's go over here. Notice what's gonna happen. If I hit the play button, we will see this one is white and these didn't change any color and stuff like that. So what I'm going to do now is select our BP static mesh, this one over here. And let's go over here inside of the details tab, and for the arrays, let's click on the plus button and add some little bit of these arrays. So these are the bad boys that we want to attach static mesh to convert. So let's go over here. Let's find static mesh to convert 1, then 2, then 3. You get the point. So you can attach all 9 that we have over here, then 4, 5. And yeah, I know it's a little bit tedious, but hey, you are here to learn, aren't you? You're not here to complain and whine like a little baby. Are you a little baby? No, you're not, okay? Well, maybe you are. Maybe babies are watching these tutorials. But anyways, I also want to attach, let's say, this editor cube 21. Let's also go here and attach this editor cube 20, for example. And if I hit the play button right now, look at that. They changed color. Also here, this is one of the cubes that changed the color. This one over here. If you want to attach this one, for example, let me click on it. It's 17. So it's the cube 17. Let me find over here and add a new array and click here. Let's find the cube 17. There you go. And if I hit now the play button, we also see the cube 17 has been converted. So basically we can convert any mesh that we have over here. Let me see this array. What is this big wall? Can we convert this? I believe we can. Why shouldn't we not be able to convert that? So BP static mesh, and let's go over here and big wall 2. Was it wall 2? Yeah, it was. Hit the play button. There you go. He is also converted into a mesh that we will be able to, destroy, because we are crazy people. And over here you can change the material. So for example, if you want the orange one, not this one, there you go. Compile and save. If you want the orange one, and let's go, hit the play button. There you go. So you get the point how this is converted. I'm going to put it back to the bluish one. So where is the fun going to happen? The fun is going to happen over here inside of our physics projectile whatever. So what I'm going to do is add here variables. So we are going to have projectile speed, and it's lowercase p. So there you go, speed. And this one is going to be type of float. So let's create 1, 2, 3 more. So this one is going to be projectile mass. We are also going to have over here a projectile or destruction radius. There you go. And last but not least, we're going to have a radial force radius. There you go. Compile and save. Make sure that all of these are public and that over here they are exposed on spawn. So you see here, we need to check this expose on spawn for every single variable that we have. So this one over here and all others that we are going to create, which we'll do in a moment. Now, one thing that I want to explain when it comes to this projectile, it has this component called radial force, which is this basically component. And the radial force component, if I hover over, you see, it is used to emit a radial force or impulse that can affect physics objects. Basically, we can detect collision with physics objects or destructibles. If I go here inside of the details tab, you will notice that we are set to detect collision with physics bodies. And also I have changed here some other settings like this one, impulse strength and all of that stuff that you can take a look at. So moving forward, we need more variables, and I'm going to click the plus button here, and this one's going to be iteration count, and this one's going to be an integer. There you go. One more integer that we're going to have is going to be max slices per iteration. So how many slices can we have per iteration? Also make sure that you expose them on the spawn. There you go. We are also going to have two more floats. So one over here, we're going to call this one explosion impulse strength. I have issues spelling these, you know, but you don't care. Why would you care? You don't care. You just care what I have for you. So minimum destructible chunk. So over here, we're going to have minimum destructible chunk radius. There you go. Also a float, by the way, expose on spawn and all of that stuff. And finally, two last variables that you're going to have. This one is going to be create new section for caps, which is going to determine if we should create new sections for the expose on spawn as well over here. For the procedural mesh that we generate, then over here, we're going to have debug. If in case you want to debug, well, there you go. This is going to be for debugging. What else can I say? Now, next, what we are going to do is set the default values for all of these variables. So projectile speed is going to be not 400. It's going to be 4,000. The mass over here is going to be 150. And you can assume from the names of these what they are going to be used. Destruction radius is going to be 150, and radial force radius, this one is going to be 600. As I said, you can assume by the names of these variables for what they are going to be used. Iteration count 4, and maximum slices per iteration is going to be 5. Explosion impulse strength is going to be 1000. Power level over 1000, okay? And over here, minimum destructible chunk radius is going to be 40. And the two booleans, you can set them to be true. It's up to you if you want to debug and all of that stuff. It is not, and go over here. There you go, nothing complicated, nothing complicated. So over here for the functions, we are going to have a function that I'm going to call perform explosion slicing, and this one is going to take an input which is going to be an explosion origin, or from where the explosion has happened, which is going to be a vector, as you probably assumed. So what's gonna happen over here? Well, we are going to, when we call this function, we're going to go inside of a for loop, like that. Not for each, not just a for loop. And for the for loop, let me just compile and save that. Where did I go? What happened over here? Static mesh. Actually, it should be over here in this one. What did I do? Okay, so just remove this. I've entered the wrong blueprint. So this, what I'm going to do now, happens over here in the projectile. So again, let me just create perform explosion slicing, like that. And again, it takes an input, which is going to be called explosion or origin. And this explosion origin is going to be a vector. There you go, finally. And I'm going to go inside of a for loop. I was looking at my variables and I didn't find any variables. So I was like, what is happening? So the iteration count is going to happen. The current value of the iteration is 4. So we're going to loop 4 times in this loop. Now what's going to happen is that we are going to have two local variables for this function. One is going to be called current iteration performed slices number. So this is going to take or count how many slices we have performed in the current iteration. And the next one is going to be current iteration. So current iteration components in range number, which is going to keep track how many current components we have in range for this iteration. Now first, when we loop, we're going to set the current iteration performed slices to 0 because we want to reset that value. Next, from here, we are going to create a sphere overlap component, and this is the one that we want to do. We don't want this one with the collision sphere or box overlap. This one, box overlap. This is the one that we want. Now, the sphere position from where we are going to do this, and this is, you can think of it imaginary sphere like ray casting. So we are going to use the origin from the explosion, which is going to be where we are going to cast. So this is where we are going to cast that sphere in order to detect, the collision. And over here for the radius of the sphere, I'm going to call the destruction radius, which is this one, and plug it in. For the object type, I'm going to simply drag that over here and make an array. So click here, make array, and not world static, but physics body. So I'm looking for collision with physics body. So only the physics body, a very awesome, nice and sexy physics body. And over here, component class to filter is going to be procedural mesh component. So we are filtering for procedural components or procedural meshes in that component, because this is what we're looking for. Next, over here, I'm going to get a reference to self, not self, but self, like a selfie, and I'm going to make an array of myself, not make noise, but like this. Make an array, right click, make array. There you go. Finally, I managed. And I'm going to put self over here, which is going to be the parameter that will allow us to ignore the actors, because we don't want to detect collision with ourselves, okay? So next, I am going to get the length from this array, which is going to tell me how many elements we have in this array. And from here, I'm going to set the current iteration components to 0 as well. Basically, to the length, excuse me again. Anyways, I'm going to go inside of the branch next, and what we are going to test is we're going to test this return value. If I go over here, and this return value, what does it represent? So what is this boolean? If I hover over, true if there was an overlap that passed the filters. Basically, this will return true if the overlap has passed the object types we're looking and the component class filter. And we're going to plug that into this condition. Now, what we are going to do is we're going to enter, if that is true, we're going to enter in a for each loop with a break. And the array that we're going to iterate is this one over here. And what did I just do? So this array, only drag it, plug it over here. I'm going to move this node, if I can move it. There you go. Finally, I was able to. So we are going to iterate through the array or every single component that we have collided with over here, that we have catched, basically. You can think of this overlap sphere as a net for fishing. So with every fish that we have over here, this is what we're going to do. Next, over here, we're going to go in a branch, and if it's false, I'm going to break the for loop. So right away, I'm going to do that so that we don't forget to do it later. And the condition for this one, I'm going to take these, move them a little bit down. The condition is going to be current iteration performed slices. And I'm going to compare this number if it's less than another integer, and that other integer is going to be the maximum slices per iteration. So if the current number of slices that we did in this iteration is less than the maximum slices per iteration, if that is true, then we are going to go here, and I'm going to say the following. So I'm going to move this here. Just a little bit more, move this here. I'm going to say cast to procedural mesh component. And who am I casting? Well, I'm casting the element from the array that we have over here, because we're testing over here. If you remember, we are checking for procedural meshes. So over here, I'm going to cast that just to double check if that is actually the case. So if we can cast it, and going over here, this goes over here. There you go. Just a little bit backwards so that we have, we can clearly see what is happening. Next, from the procedural mesh component, I'm going to test if is valid. And I'm going to test if the mesh itself is valid. And then I'm also going to get the component bounds from this mesh. And I'm going to plug this in like this over here. And what I'm going to do with these bounds, because we are going to enter a branch over here. So a branch is a true or false, as we already know. I don't have to mention that because that's basic Unreal Engine. Now, what I'm going to do here is I'm going to take the sphere radius and I'm going to compare it if it's less than, so if the sphere radius of the procedural mesh component is less than the minimum destructible chunk radius. If that is the case, but I'm also going to say over here not. So basically I'm testing if the sphere radius is not less than the minimum destructible chunk radius, then this one goes over here inside of the condition. What's gonna happen is that let me just move these two first, this one as well. What's gonna happen, if that is true, I'm going to take the origin from this component and I'm going to say a random point in bounding box to get the random point from this box. I'm also going to take the box extent and divide that by a float, and that float is going to be 2. So because I want half of the current size of the component that we have collided with, because now we will create new components. And that is going to go over here. So from the true branch, I'm going to say slice procedural mesh. There you go. So this one return value goes in the plane over here. For the plane normal, I am going to generate a random boolean. So random bool. And from this random boolean, I'm going to generate a random rotator for the random rotation. And from the random rotation, I'm going to get rotation x vector. So I'm going to get the x vector and plug it in over here. Yes, I want to create other half. There you go. This one is moved over here. The cap material is going to be MI material. You can also set the orange one if that is what you prefer. And for the cap options, I am going to go inside of select. And over here, for the first option, we're going to say use last cap, and over here we're going to say create new cap, and the condition is going to be create new selection for caps. If it's true, we're going to create. If it's false, then we are not going to create, we are going to use the last one. And in which mesh do we do that? So over here, in which mesh do we slice, or basically which mesh are we going to slice? Well, this one over here, this is the procedural mesh that we want to slice, so plug that in over here, and this one goes here, then this one goes here, so that we can see clearly and don't get into the spaghetti node code. Make sure that you compile and save that. And the last step that we need to do is we need to set simulate physics. And we are going to do that for the newly generated sliced part. So click the checkbox. And from there, I'm going to take the current iteration over here for the slices that we are keeping track of and say plus plus, because we want to increase it by 1 so that we indicate that we have sliced one part. That is basically what we are doing. Now, moving forward, and essentially, in short, what this is going to do as this function, it is going to cast a sphere at this direction, or actually this location, looking for collisions with these types of objects, so the physics body, and looking for the procedural mesh in that physics body, and then it's going to get that. So if we do have, so basically, if we do have this condition, so if we sliced or if we collided with these objects, then we're going to loop through these objects and slice them to create, you see over here, we are slicing those objects to create new meshes from them. And this is what we're doing. So over here in the function, click on the plus button to create a new one. And for this new function, I am going to call it perform hit impact slicing, which means when we hit something with when we hit something with the projectile, we are going to slice that. And the first parameter is going to be our hit component. And you can assume the hit component is going to be a procedural mesh. So over here, I'm going to say procedural mesh component, and we're going to get the object reference, and the next one is going to be impact location, which is going to be a vector, which is clear. Next over here, first when that happens, we're going to test if is valid, and we're going to test if the component object is valid. If that is the case, we are going to enter, and this one goes here. If that is the case, we're going to go inside of the branch. The condition for the branch is going to be from here, from the component, I'm going to get the component bounce like that, and this one can go here, something like that. So getting the component bounce, and from the bounce, I'm taking the radius, and I'm testing if it's less than the float, and this float is going to be minimum destructible chunk radius, which is going to be plugged in over here. And again, I'm going to use the not. So if it's not less than, and this is going to be plugged in as the condition for our branch. If that is the case, if it's not less than, then from the true, I'm going to say slice procedural mesh. This one goes here. And we are going to slice the mesh. First things first, where is going to be the position? The position is going to be the impact location. So I'm going to plug that in over here. Just move this a little bit down. Move this also here. There you go. In which procedural mesh are we going to do that? Well, in this one over here. So take it from here, plug it in. Again, double click on it and move it over here so that we can make sure that we don't get into the spaghetti node code. There you go. The plane normal, again, I'm going to generate it by using a random bool. And from the random bool, I'm going to generate the random rotator. And from the random rotator, I'm going to get the rotation x vector. And I'm going to plug it in over here for the plane normal. There you go. For the material, again, I'm going to use the MI mesh material. For the cap, I'm going to go inside of the select, and you can assume I'm going to again say here create and plug that in. If it's true, we are going to create a new one. If it's false, we are going to use the last one, compile and save that. And that would be pretty much it. We do need to click here, create other health as well, and we need to make sure that we set simulate physics so that the newly generated parts will simulate physics, and make sure that you check the checkbox. And that would be pretty much it when it comes to R2 functionalities or functions, however you want to call them. I don't care, because that's on you. You call your functions weird names. Anyways, going here into the event graph, I'm going to right click and get the begin play. And from the begin play, what I'm going to do is set all physics linear velocity. And I'm going to do that for our collision sphere. So what's gonna happen is, if I hover over, set the linear velocity for all bodies in this component, which means it's going to set the linear velocity for the radial force and the particle system, which are components of this, you see over here, for the all, how did it say? Bodies. So all bodies from this component. What I'm going to do is right click and get the actor forward vector. And from the forward vector, I'm going to multiply it with a float. And that float is going to be the projectile speed, this one over here. So the forward vector multiplied with the speed, I'm going to plug that into the new velocity, and there you go. Next, what I'm going to do is I'm going to take the sphere again, and I am going to set mass override. Then I'm going to override the kilograms of the mass for the sphere component, and I'm going to take the projectile mass and plug that in over here. Everything else is going to be as is. And last but not least, I'm going to get my radial force, and from it I'm going to set the radius. It's radius, not the radius, it's radius. There you go. And the radius value is going to be the radial force. There you go, plug that in. I am also going to get here from the radial force the set impulse strength, like that, and move this over here, something like that. This goes here, plug it in, voila. And I'm going to take the explosion impulse strength variable and plug it in over here. Simple as that. Compile and save that. This is what we are going to do in the begin play. Next, I am going to get the hit event. So I'm going to say event hit, which is the, if I hover over, why isn't hovering over it? There you go. Event when this actor bumps into a blocking object. Basically, translated with normal human earth words, when we collide with something, this hit event is going to be activated. And I'm going to go inside of a sequence. And the first thing that I'm going to do in this sequence is I'm going to say do once, which is going to only do once, so perform the operation once, and that operation is going to be the delay. So I'm going to go here into the delay, and I'm going to leave delay at 0, but in case you want to delay for, your purposes, I'm going to leave it as is. So you can set that value however you want to set it. And after that, over here, it will be in the destroy. So destroy actor. There you go. So what's next? And this goes over here like that. And these two go here like that. Voila. Because we're going to plug in new things over here right now. Because after the first sequence, so after that sequence finishes, I'm going to go here, I'm going to say cast to procedural mesh component. And who am I casting? Well, I'm going to cast the other component that we have collided with to check if it's the procedural mesh. And if that is the case, I'm going to say here do once. And I want it to perform, so I'm going to say perform hit impact slicing, and then from there this is going to go and do the same thing. But who is going to be the hit component over here? The hit component is the procedural mesh component. If that is the case, if we hit a procedural mesh component, there you go, and this goes over here. And the impact location is going to be the hit location from the event hit that we get. So double click here, and move these nodes around, or basically I don't know how these are called specifically, this right here, pins for the nodes. There you go, move the pins for the nodes. That is it. Next, I'm going to get another event. So event radial damage or radial damage. I don't know how to pronounce things. When this happens, I'm going to say do once, because in case the radial damage is done multiple times, I'm going to say here destroy actor. There you go. This is everything we need for this event. And the last step is when we get destroyed. So over here, event destroyed, which is the event that will be called when we are destroyed. So compile and save that. Called when the actor has been destroyed. And what's going to happen when the actor is destroyed? I'm going to go inside of a sequence. And this sequence, the first thing that I'm going to do is turn off. If we have debugging, I'm going to turn it off. So I'm going to go into the branch over here like that. Move this a little bit down so we have space. And I'm going to take the debug Boolean variable, and what I'm going to do is go here and draw a debug sphere. So this is if we are debugging. If we are not debugging, we are not going to do that. So draw the debug sphere, and we're going to draw it at the actor location. So right click, get actor location. Send me location, okay, send me location. We send Habib location, and the force is going to be the radial force, which is the radius over here. The duration of this sphere is going to be 0.5, and the color, I don't know, you can set it to this bluish color. That's up to you. This is not bluish color. I don't know, you get the point. So do we have color presets? No, I'm not going to search for the color presets. Let's see here. There you go. Maybe now it's blue. I'm going to call it blue, okay? I'm going to copy this and paste it because I'm going to draw another debug sphere at the same location with the same radius, but this time I'm going to use 0.5 for the duration. That is okay. And the color is going to be different though. Over here, let's pretend this is a red color, okay? So compile and save that. So this is the first thing that we are going to do when we are destroyed. We're going to draw a debug sphere. If we are after that, actually, for the sequence, then we're going to say perform explosion slicing. And we're going to slice at the actor location. So get actor location. There you go. Send me location. Habib now has your location. And then I'm going to get the radial force and the fire impulse from the radial force, or basically call it. And then from there, I'm going to call apply. So apply radial damage. It's radial, come on, damage. There you go. And the damage is going to be done at the get actor location, which is going to be plugged into the origin. The damage radius is going to be destruction radius. Here it is, destruction radius. The damage type is going to be damage type. And over here, the damage causer is going to be self. So let's go and find our reference to the self. We are the damage causer. We're going to do the full damage. And we are going to, damage prevention channel is going to be the physics body. That would be it for this one. And let's go do some last things, which is going to be spawning. So spawn emitter at location, not locati, it's location. The location again is going to be get actor location. So we are spawning emitter, which is going to be a particle emitter at that location. So we want the explosion, which is the, explosion where we hit with the projectile. And last but not least, we're going to set the world scale 3D for that component. So let's go here. The scale is going to be 333 for all 3 axes of this component. Before we can actually test this out, we do need to go here, make sure that everything is working here. So compile and debug. Actually, I'm going to do it like this. BP projectile actor. Actually, I need to remove this. And then from here, I need to spawn actor from class. There you go. And the actor is going to be projectile. Voila. At the transform over here, this goes over here. There you go. So compile and save that. Now you can change these if you want to. So you can change the, I don't know, the radial force, the iteration count slices, blah, blah, blah. Should we debug? Should we not debug? All of these things are up to you. So you can do that however you want to do it. But yeah, basically we are done with setting everything up. Which means now we can go here in our game, we can test it out. So if I hit the play button, now we should be able to slice all of these bad boys as we can see. And also, I think we saw, look at that. So that was that sphere that we're drawing if we're debugging. And there you go. We can even destroy these walls and everything. And if you change this over here, you can change the iteration count and maximum slices per iteration. So we can have more than 5. We can have 20, 30, 40, 50, however, or how much you want to have them. And there you go. There you go. And we cannot slice this because we did not convert this into a sliceable procedural mesh, whatever. But anyways, this is it. If you want more advanced stuff, join my academy. Link is down below. Just click on it. I don't know if I'm running some promotion, but if you are on my email list, because that's where I'm running the promotions, rarely do I run them here on YouTube. So just join my email list. You will get nice and juicy emails to laugh and learn something from. And I'm going to shut up, just go and join the academy and subscribe for more. And I will see you guys in the next video.